welcome to today's Learn Live session for Cosmos DB. In today's session, we're going to be talking to you about how to enable analytical processing over your operational data in real time using Azure Synapse Link. I'm Gary Hope. I'm a program manager on the Cosmos DB team, and I'm joined today by Rodrigo.
Hello, everyone. My name is Rodrigo Souza. I'm also a PM with the Cosmos DB team, and let's learn how to unlock analytics and reduce costs with Azure Synapse Link for Cosmos DB.
Awesome. Today's session is a Learn Live session. We're going to be covering the Learn module that's available. Learn is the Microsoft platform for free interactive learning exercises. It includes a hands-on lab environment where you can go and develop your new skills. Today's session, the hybrid transactional analytical processing session, is one module within a learning path. We're actually going to cover a little bit more than just what's in this one module. So be sure to explore the learning path more fully. Today's session has got a lot of content in it. Don't be overwhelmed. We're going to step you through step by step and help you understand each of the pieces. We're going to help you understand what these processing patterns are that we're talking about when we talk about hybrid transactional analytical processing. We're going to help you describe the workloads that we can support using this pattern. We're actually going to talk about the scenarios in context, so how they relate to the technology that we've actually got in Synapse Link to enable them. We're going to talk a lot about the analytical store, which is the functionality within Cosmos DB that unlocks all of this capability, and then how to specifically design and enable schema for that nosql data that you've got stored in your Cosmos DB from within the relational processing that you have within Synapse. And then do a complete end-to-end scenario where we can talk you through the plan that you would need to put together to expose the schema and query the data from within Synapse. So today's session is live. Welcome everyone to the live session, and please take advantage of the live chat. Welcome Robin from Chicago and Pradeep from Dallas. We've got Ashley here from Seattle and Sergio from Brazil.
I think we have a big Brazilian audience.
We have a big following, do we? Cool. So please interact with us in the chat. It's your opportunity to ask questions. It's your opportunity to get the answers as we work through this content. We're gonna work through the content. Don't follow along in the learning path directly now. Go afterwards and understand what needs to be done additional. All of what we've got here is already there. And thanks to all our SMEs who will be supporting us as moderators from within the chat. Rodrigo and I will attempt to answer some of the questions, but we also have great SMEs in the chat that will answer your questions as we move through. I think with that, let's dive straight in. We've got a lot to cover today. Let's dive into the content.
Yeah, so
over to you, Rodrigo.
Yeah, let me get started. So before understanding what is hybrid transactional and analytical processing partners, what we had before, companies used to separate transactional and analytical processing to avoid these two kinds of workloads competing for the same resources, for the same compute and data resources, right? And HTAP is the idea of HTAP is kind of to save our customers to manage all this work they need to do to separate transaction and analytical. So it's hybrid because it has both. So let's go to the next slide. Oops, yes. So Azure Synapse Link is our HTAP cloud-native solution for analytics on top of your Cosmos DB data, right? And how it works. Your data, your applications will ingest data into regular Cosmos DB containers, and let's call it transactional store. This is a row-oriented storage, and it's great for transactions, but it doesn't work well for analytics. Synapse Link, behind the scenes, automatically will sync this transactional data into a columnar format that is optimized for analytics. And this columnar format can be read through Synapse Link, our cloud-native HTAP connection between Synapse runtimes and Analytical Store. And a couple of interesting points here. First one, this sync process between transactional and Analytical Store, it doesn't use customers' RUs. So it's free for customers in the sense of RUs. And Analytical Store storage has 10% of the cost of transactional storage. So it's very effective to retain data for longer, for analytics, right? It's really important to have access to all your history of data. So it works very well in this sense also on the storage costs. And when customers are using Synapse Spark or Synapse SQL to read from Analytical Store, again, they are not using RUs. They are just using the regular Synapse runtimes billing methods, right? They will be charged by terabyte scan in SQL serverless. They will be charged by vCore hour in Synapse Spark, but not RUs anymore. So it's really important because now customers can run heavyweight queries, not burning their RUs or not providing RUs for this kind of workload, right?
And they have access to those rich analytical query languages as well, not just the resources, but also the languages associated with those query engines.
That's a key benefit. This is one of the most important benefits of Synapse Link, right? Because Synapse Cosmos DB SQL language is a subset of SQL ANSI. So customers can't run T-SQL short procedures. Customers can't do joins,
windowing queries, any of those types of rich analytical operations.
Aggregations are so complicated. So cross-partition queries, so queries that touch more than one partition, they are slow and expensive. Now customers are free of all of that, right? But let's see the key benefits of Synapse Link. First one, we will automatically sync transactional analytical data, means that customers don't need to manage storage, ETLs, so customers get rid of that. There is no performance impact in your transactional workloads anymore, not the sync process, not your analytical workloads. In near real time, what is near real time? We'll make your data available for analytics in up to 2 minutes for most of the workloads. From the cost perspective, we can avoid the RUs usage, as I mentioned before. It's Synapse runtimes. They have this consumption-based in pricing. It's very, very affordable. We can move expensive cross-partition queries to where we should do it. That's Synapse Analytics was built for that. Also, I mentioned that we can keep your hot data in transactional store and keep all of your history of data in Analytical Store. That's a key capability for Synapse Link. As an example, today, Cosmos DB will charge you minimum RUs per gigabyte. So if you're only keeping hot data in transactional store, you will need less RUs, right? So it's really important. Let's see the next slide. We have this brand new native integration with Synapse.
Could you say that?
Sorry, my watch is talking to me. We have this one-click integration with Synapse Analytics. We have two, actually. We have this integration with Synapse Workspaces, but also the new Power BI integration. So I think you're going to show it in the portal later.
I'll briefly point it out as we go through the enabler.
Satya was using that yesterday in his keynote. Yes. We already mentioned T-SQL language. Another important benefit. Today, customers using Cosmos DB, they need to define a data model that will bring balance between reads and writes. And now they can focus writes. We're going to do writes somewhere else. So they don't need to worry with that anymore, and they can focus, they can optimize their data model, the data modeling for data ingestion, for transactions, right? So that's a key benefit that will bring performance optimization and cost reduction.
So I can focus on my operational workload from the transactional store, and I can focus on the analytical workload from my analytical store using the Spark and SQL processing engines.
Exactly.
Cool. Let's dive in and actually show some of these scenarios specifically and what we can perform using them. So here what I've got is a Cosmos DB account. I've just created this, so it's not enabled for anything new. I've just created a SQL API account. And I just want to quickly show you what you need to do to enable it. We've exposed the Synapse Link capability in several places. If you go into your features, you'll see there's Synapse Link, and by default it's off. You can turn it directly on here. There are the two pieces of functionality that Rodrigo was referring to earlier, the ability for us to just enable and integrate directly into Power BI. We're not going to cover that in today's session, but it's definitely worth something worth exploring. And then enabling the actual Synapse Link functionality directly within the Synapse Link function, there's an enable button as well. If you've got data set up in your environment, you'll be typically using the Data Explorer. And within Data Explorer, there's an enable Synapse Link button. All of these options achieve exactly the same thing. By clicking enable, what I'm going to do is I'm going to turn on the Synapse Link functionality for my account. Let's switch to a Cosmos DB account that's already enabled. Here I've got
a good point here is to mention that after you enable at account level, now we are ready to enable in our containers.
Correct. So we've enabled it. It'll take a few seconds to enable. I've just switched over to a new account, an account that I've already enabled. The next thing you're going to need to do is enable it on your container. Now, when you create a container, you will see that there is an option down here to enable the analytical store. By turning this option on, you enable that analytical store from the time the container is enabled. If you have containers that are already deployed, from within the SQL API, you can actually go in and enable those containers after the fact for an analytical store for Cosmos DB. Let's have a look at what we need to do once we've enabled that from within Synapse itself to provide connectivity to our Cosmos DB data.
Yeah.
So here we go. Let's go into our data tab. You'll see here now I have a bunch of Cosmos DB accounts that are already linked. So the Synapse Link is enabled for these Cosmos DB accounts and they're exposed here. But in order for them to be exposed here, I have to actually add them to my linked services. And the way to do that is I go into my linked accounts. I click connect to external data. I connect on SQL API. And I specify the name of what it is that I'm connecting to. And over here, you will see that within my subscription, I will now see that account that I was working with earlier. So in this case, this is called, sorry, that is not the account we were working with earlier. It is called this. It's a long, complicated name. And if we use this account,
there is a white space. Yeah.
You will see that it will show us all of those databases there that are enabled. So the one that we had, example, database 1, 2, 3, 4, is exactly the same as what we have here. We have our example database 1, 2, 3, and 4. Once I've done that, and I click OK within my linked service, it will add, I'm just going to cancel out of here because we've already added one. It'll add it to this environment. So if I go and have a look at one of the example containers that I've got, here's an example. It has some items in it, a couple of documents, and we'll talk a little bit about the content of these documents. But this is our NoSQL JSON data stored in Cosmos DB. When I go here and I have a look at exactly my example, you can see in brackets here, it shows me the database, the account name. And within that, you can see the actual database itself, the container itself. And if I have a look here and do a select on those top rows, what I'm going to do is I'm going to get back a select statement that allows me to directly query it. While that runs, I'll just quickly talk about what's happening up here. In order for you to configure Synapse Link to connect to your Cosmos DB account for the first time, the easiest way to do it is to create a credential. And in this case, we name the credential the same as the server name. And we provide the connection string information associated with that. That includes the actual key that we have for the container or the account.
An important comment as well is this is a serverless service, right? So
Correct.
The first execution has this cold start delay.
Correct. So you saw it took a few seconds for it to come up with the results. Here you can see the results that we have from our container. We have some rows of data, and it represents what's in our Cosmos DB container. And we'll explore that a little bit more as we go through and understand how we map that schema. But that's the basics of how we get that data through to our Synapse environment. And you can see that it's super simple to do that.
Yeah, so now let's talk about some supported scenarios. So actually, it's a common question we have. Oh, does this industry works with Synapse Link? Any customer in any industry willing to do analytics may benefit from Synapse Link. With that said, let's see how it would be done for supply chain, for real-time personalization, and predictive maintenance. So this is a supply chain scenario. We have this reference architecture. And what is interesting is that, as you can see, we have multiple data sources ingesting data into Cosmos DB transactional store. Behind the scenes, Synapse Link is syncing with Analytical store. And then we have Azure Synapse Spark and Azure ML. Azure ML SDK is built in Synapse Spark base image of the cluster, right? So we can see that we have probably a data scientist preparing and training a model for predictions. And there is a line when they are writing data back to transactional store, probably the predictions itself, they are being stored to further use it. And at the same time, in number 2, we have Azure Synapse SQL Serverless serving Power BI dashboards for near real-time reporting. So that's a common scenario for supply chain and forecasting reporting. So let's see the other one. This is a real-time personalization, and something really important here, real-time personalization. So let's say we don't have Synapse Link. So you need to run an ETL job to export the data into somewhere else, and another process will read this data, we're gonna predict, we're gonna use machine learning to detect. So there is no real time when you need to manage data export, data import, data export. With Synapse Link, it's near real time because the data is available for analytics in up to 2 minutes. So this kind of scenario is hard to deploy without something like an HTAP option like Synapse Link, right?
So the options are that once the customer has a trained result set, we can distribute that data out using Cosmos DB back out to the transactional environment for them to be able to consume that. So it's not just the ingestion part, but it's also the distribution of those trained result sets back out to the stored data back out to the operational systems, right?
Yes, after Azure Synapse Spark did the personalization, so the personalized data is ingested back in Cosmos DB transactional store because no database in the planet will be faster to read 1, 2, 3 documents from transactional store. We have this SLA for less than 10 milliseconds. And this Kubernetes application can leverage this throughput Cosmos DB has to serve the information back to the users in near real time.
Right.
This is a similar scenario, just to mention that IoT is a very common, typical scenario we have for Cosmos DB. And of course, IoT customers, they benefit from Synapse Link for predictive maintenance, anomaly detection, and things like that.
Cool. So that covers our scenarios. Let's talk a little bit about the actual HTAP process itself and why we have this HTAP process and the benefits that it brings. So as you mentioned, Rodrigo, it separates out the performance characteristics of the analytical and the transactional workloads. So in our customer here, I'm going to use AdventureWorks example data set. The customer is very happy with the operational characteristics of Cosmos DB. It provides them with that high throughput, low latency transactional operations using the transactional store. But it becomes challenging when we want to run these more complicated analytical type queries. SQL provides us with that rich processing characteristic. And in today's session, we're going to be focusing on the SQL Server, the SQL serverless functionality within Synapse. The SQL surface area, the T-SQL language itself, provides us with that rich interaction capability that allows us to enable these operational workloads to surface insights in real time for us using that very rich language itself. The scenarios that you've spoken about have focused to some degree on the machine learning components. Again, we're not going to touch on much of that detail. We do cover a little bit of that in the learning path. So when you go and explore the learning path, don't just stop at this module. Go and explore those other modules where we drill into that in a little bit more detail. So let's talk a little bit about the actual analytical store itself. So in this scenario, we've got this column-orientated analytical store. It's optimized for those scan-heavy queries. So when we write that rich language query that is going to perform our analytical processing, it's going to want to process across large volumes of data. And those volumes of data are scan-heavy. That we're going to need to read through large amounts of data in order for us to, example, summarize the data that's in our table, in our container, using the rich analytical query. Where we compare that with the row-orientated transactional approach, where we want to have that low latency interaction, the thing that's going to be more important for us there is how quickly we can write away that record or update that record or even delete that record. In those scenarios, the thing that's the most important for us is how quickly we can do those operations. In the transactional store, we actually account for those, as Rodrigo mentioned earlier, using request units, which is the unit of currency that we use to measure the throughput that we provision for a Cosmos DB container. So you provision a certain amount of what we call request units or RUs, and you consume down against those, and that is what provides you with the ability to transact against that environment on the transactional store. For those queries that are processing against the analytical store, we don't have any of that.
It's interesting because the columnar format is not only built for analytics, it brings this natural compression of the data. So again, it helps the performance of analytic workload.
When you're doing those big scans, you don't want to be scanning each and every individual character. You can leverage some of those compression characteristics that we have underneath.
Yes.
Cool.
So,
oops, sorry, let's just go back a few slides. So, as we mentioned, we have this auto-sync process. This auto-sync process is going to take the transactional store data that in our case is represented as a document, and it's going to rewrite that into a relational format or a relationally queryable format available inside our column store. This auto sync process is not just responsible for moving the data from the transactional store to the analytical store, but for mapping the schemas in terms of how we operate on that data within the analytical store once that data has been rewritten there. When we enable it, by default, I showed you that you can enable Cosmos DB Analytical Store when you create an account. Now, it's important to understand that that is available for both MongoDB and SQL APIs. But today, we can only enable the SQL API once you've actually loaded data into the account. MongoDB API, you need to enable it when you do the account creation.
We are working on existing containers for MongoDB. It's coming soon.
So, Rodrigo, do you want to talk to us a little bit about these schemas? I spoke about how that sync process does the transformation of those schemas for us. Let's drill into a little bit of the details around how that happens.
Yeah, so the auto sync process, it transforms semi-structured data into structured data. Columnar is structured. So what is the magic, right? We had to implement ourselves a couple of rules, constraints to do this transformation. And for that, we have a couple of limits. It's important to understand how it works, right? Even to model your data in advance according with these constraints we have today. So today, as an example, we support 1,000 properties, 127 nested levels of data, and we are case sensitive, right? And more, we have restrictions or kind of rules about data types and things like that. So our suggestion is to check our documentation, because I've been documenting every single detail of this transformation is there.
Perfect. So at a high level, we have these different ways of mapping it as well, right?
Good point. Yes, we have. For SQL API, the default option, the default method we have to do this sync between transactional and analytical store, we call it well-defined schema, meaning that we have specific rules for SQL API, meaning that if you have a property with data type A, and suddenly you have a document where the same property has data type B, that value won't be represented, because we assume that it is well-defined. The data model, the schema of your documents is well-defined, right? This is one of the constraints we have. And so if you could go back to slides. We also have an option, we call it full fidelity schema. This option is available for SQL API by using CLI or PowerShell. But for MongoDB API, this is a default option for containers.
And we'll show you a little bit about that in terms of these schema mappings and how they're different in terms of the two APIs as well.
Your demo for this is great. I love it.
So here's an example of a document that you were talking about, where we have an address embedded here. So here's a document. It has an ID. It has a document type. It has a name. It has the customer identifier for this this customer record, and an address. And you'll see represented in this document, the actual street number is represented as integer here. There's no quotation marks around the number, and it will infer this well-defined schema from this first instance of this document. Now, if another version of this document came along and it had string defined here, that would be a challenge for us. And these are some of the rules that Rodrigo was referring to in terms of how we do that mapping and which takes precedence in the well-defined schema. Let's have a look at it practically rather than in theory. Let's go drill in and actually have a look at an example. I was talking about these two records, and these two records here that we looked at very briefly earlier are exactly this. we have a customer, and if we have a look at the address in this first record, you can see that their street number is represented as an integer. And if I go and query this data, let's go across to the Synapse, and let's have a look at this script here. So this is a query of that data. You can see this ID that I've got here is the actual document ID that we've been talking about. So hopefully, when I run this query, what we're going to get is it's going to go into the analytical store, and it's going to find that analytical store representation of exactly this row that we've got. And here you can see that we've got a column for every property that we have in the document: the ID type, customer ID, address, and the system properties. ID type, name, customer ID, and address are represented in here. You can have a look within this address, and you can see here this is an embedded document, the address. In this case, we can go and pull out this address, and I'll just do a copy and paste here. It's actually here above as well, but here's the value coming directly out of the result you've got here. And you can see the street number is represented as a numeric value in here, and it's the inferred schema that we have here. If we go and have a look, though, there's another version of this document, 29. It ends in 29, and this one has a street number that is a string. It's in quotes. And this data, if we go and query for this data, so if I look for 29, we will see that this data, let me just run this. We will see that this data is represented here differently, because we've inferred that schema at the first creation, and then on the second document creation.
The first document of the collection defines the schema.
Correct.
So if the second document isn't following that schema, it won't have the property.
So you can see in our address properties here, that one is missing. That street number property is actually missing from our document completely, because it had a different type, and it was not the one that was defined when we created the document. So an interesting one of the rules, and something you need to be aware of, that you have a stable schema when using the well-defined schema, if you were expecting those properties to all show up in your result set.
Yes.
That doesn't mean just because we've got this mapping that we need to be dependent on this mapping. We can actually remap the properties from within the document into something else. Perhaps I only want the customer ID, the customer name, and a postcode for that customer. And I want to expose that directly as a result set. I can do that by using this with statement, where I map into the actual document and extract the properties that I want as columns within my result set. So now I have a result set that just contains those three properties. If I did it without the filter, I would get both of those documents back.
This is a good practice, because you can optimize the data types of your columns.
Right. And if we have a look, let's switch over now. We spoke about this MongoDB account. Let's go and actually have a look at a MongoDB account. I have the same data here configured here. You can see this is a different account. It's a MongoDB API account. And within this container here called MongoDB sample, I have a document that has the same characteristics. Again, it has the street number as an integer. It has the street name as a string. And if I go and query this document, or documents that are in there, let's have a look at what we get back when we run this query for the full fidelity schema. So everything at first glance appears to be the same. I have the same system properties, my RID, my TS, my ETag. I have an ID. I have an object now in my address, and that object looks a little bit different. If I have a look at what these two objects are actually represented here, you can see that they have street number, which is the 2 street numbers that we have, one of them has another property within that street number called int 32, and it has a value that is an integer value. Whereas with the other record, I have a property within it called string, and that has a string character representation of that street number. So in this scenario, my data is coming through to Synapse, through that Synapse link, when I've enabled it with this full fidelity schema. And as you mentioned, Rodrigo, just to remind everyone, in SQL, the default is to have the well-defined schema, and in MongoDB, the default is to have full fidelity schema. SQL, we can actually turn on full fidelity schema as well, if we want to at that stage.
And that's why we call it full fidelity, because it doesn't matter the data type. We're going to just add the data type as a label for that column, and all data is represented.
So I think we've discussed the full fidelity and well-defined schemas. We kind of showed them in demos rather than in the slides. Let's talk a little bit about the design for schemas that we have. What design considerations we need to have when we design schemas. The examples that we've used so far are very simple. It is not typical for us to have a document that is very flat, and the most complicated thing that we had in this document was that we had an embedded address. We're much more likely to have a rich document that has different levels of embedding, so multiple levels of embedding. And as Rodrigo mentioned, we support up to 127 levels of embedding. But it could also have other things, and other things could be storing multiple document types within the same container. So let's go and have a look at a scenario that looks like that.
And this is very typical in Cosmos DB.
Very typical. Customers tend to take advantage of those NoSQL characteristics when we look at that data stored in the NoSQL database. So here we have a customer container. And you can see there's a whole bunch of documents in this customer container. And you can see these documents are slightly more complicated. The address, there's not a single address. It's actually an array. You can see the array indicator here. And there's an array of addresses. In this case, there's only one. But in other customer records, there could be multiple. The other thing that we have is that we have multiple document types. You can see this is a customer record, but if I go and run a query on this environment and I look for all the customer records, you can see that we end up with a whole bunch of records here, and they're all of a customer type. You can see they have a first name, a last name, an email address, the address details, and there's multiple in here. At the very top of this record, there is something called an object discriminator type here, where we tell
the second one.
That's the
second property. Right after ID.
Yeah, so where we tell the record what type it is. Because it has the structure, we can now filter out those records that have the structure because we put this discriminator property type that tells us what they are. I can also go and have a look in the same container. Now, I'm running this query in exactly the same container. I'm also storing my transaction data. And you can see the transaction data here contains a transaction header, when it was ordered, when it was shipped. The details of the transaction is stored in an array. Again, we have another array here. And within that, we have a whole bunch of line items that all make up that order detail. And we embed that within the document itself. It's more efficient for us to build this transaction into a single document because we do things like query it together and interact with that data in a standardized way. So these rich containers that contain these multiple documents are now exposing for us multiple entity types that we have. So when we embed these objects inside each other, we're going to want to do that based on a set of rules. And this is some of the rules that we use to think about when we design these documents. We want to understand.
Embedding is a key data modeling technique for Cosmos DB.
Absolutely. For most NoSQL databases, especially document databases, that embedding concept is well adopted, and it follows, generally people follow these types of rules in terms of when to do it and when it makes the most sense. So when the relationship between the two different entities are contained within the other entity, it makes sense to embed it, right? I've got an invoice header and an invoice detail. It makes sense to put the invoice detail within the header. They're related and they're always related. When there's a one-to-few relationships, I typically don't have invoices that have millions of lines on them. It's typically an understood length of invoice for the number of transactions. It makes sense then to embed it in my document. And the data between the two entities changes infrequently. My header and my invoice detail gets updated infrequently. It doesn't carry overhead for me to update the detail or the header separately. I don't need to worry about that.
And Cosmos DB SQL language doesn't support joins. So the way to get all this data from all orders from one customer, you need to access one container.
Correct. So this leads us to this document format that we've been talking about here. And these documents, when they're stored in one container, allows me to return my sales data and my customer data with a single query as well. Let's go and have a look at actually what it means to interact with this data. Let's go to our Synapse environment and actually have a look at what it means to interact with this data. So here I'm back in the Synapse environment. I'm going to open up another script. And this is connected now to that same container that I was talking about earlier. If I look for the customer data, so I'm going to go and query for all of those records that are customer records. I'm specifying that the filter is on this type customer. I get a row for every customer record that I find. And you can see it has the right properties for this record. It has an ID, an email address, a type, a customer ID. Those all make sense for the customer. But at the end here, there are things like order date, ship date, and details. Those properties don't relate to customer. And if I do the same thing for sales order, we'll see a very similar pattern for sales order here. So my sales order data will return the sales order rows now. It doesn't have email address type is for both of them, but customer ID is for both of them. The last name, first name, phone number, that only relates to the customer record. So I've now got the sparse result set. And then I need to use that ability that we spoke about earlier, where I provide this with statement to map out those properties that I want. So in the case of customer, I'm going to create a view. So I'm going to create a SQL view that represents the things that I want back from this customer data. And I'm going to choose to map out those properties directly to the columns for this view. I also want the first address, and I'm going to apply this address detail. In this case, all that I want from the address is the country, because I want to do some analysis around what customers bought what products from what countries. So in this case, what I'm going to do is I'm going to open the JSON, that address detail that was in the JSON address property, and I'm going to extract the country from that property. And this cross apply will then create a single row for me that provides me with the customers with just these properties associated with it. And we'll have a look at what that view looks like. I'm going to do exactly the same thing for the sales order. And the sales order has two parts. It has that header part where I'm going to want to get back a row for every header. And in the case of a header, I want the customer ID, the order type, and the ship date to be surfaced. And I'm going to filter based on the sales order type. So I'm only going to get those sales orders. But remember, within the sales header, there are the actual sales line items themselves. So I want the sales order detail. And here I can go and open this and map into the actual order header. I'm going to extract the header details, and I'm going to do a cross apply to extract the sales order details. And here I get back the SKU name, the price, and the quantity. So I get these two tables now that I can interact with as I would a normal relational data set. So here's a quick query to have a look.
The cross apply function makes a join between the nested data and the external data.
Correct. So if we do this, if we have a quick look at just what this table looks like. So my sales order data now has cross-applied the SKU code, the SKU name, price, and quantity against the data that it got in the header, which is the sales order ID and customer ID. So now I've got a sales order, a customer ID, a couple of other properties from my header here, and then my SKU code, my SKU name, and my price. And this now allows me to do these analytical queries that we were talking about from my operational data. This is going to go and do a summary of SKU code, and it's going to give me the total sales, the price times the quantity for all of my SKUs across this data. Now, this has got a fairly large data set in it, and this type of processing would have been very expensive in terms of RUs if I did it on a transactional store query and used request units to actually provide the query capability for that. Lastly, we can quickly run a query that gives us the result set by country. So now I'm doing a summary of all the data. I'm grouping by a property of another table. And you can see I've got my SQL join syntax available to me. I can join these two entities together, and I can do a group by statement, and I can get back my summary. So very rich analytical processing characteristics that we've got.
And two important points here in this script. Three, actually. First one, right on the top, you specify the collation of the database. And that's important because UTF-8 collations allow SQL serverless to push down the filters to storage and to filter data. Second, when you create these views, you can expose them as they are tables for end users using Power BI, as an example, right?
So this customer table, someone using another tool would connect to it and just connect to it in the normal interactive way that they would normally expect to interact with a SQL table.
And we are hiding all complexity from end users using the views, right? And then work with Power BI or any other BI tool as they are used to, right?
So as long as you've done this mapping to separate out using your type discriminators, if they exist, in other words, if you have documents of different types stored in the same container, you need a view per type of document that you have, and you use that type discriminator to separate those out. And then if you've got different properties that you want to project out, you can then project out those properties, whether it be just a projection from within that document into a flat structure, or from within arrays within that document into multiple tables. So in our case, we've got customers, but we also have sales orders, which is the header, and we also have sales order detail, which are all the details.
Yes. I also, to close, I also call out that, let's say this customer, this company, they also have some data in data lake, right? In CSV or Parquet format, doesn't matter. They can create an external table pointing to that folder or to that file and join Analytical Store, as you are doing here between these views, with the data in data lake.
That also makes sense, right?
Yeah.
Let's have a look at what else. Just to summarize, when we think about scale in the transactional store, we're thinking about scaling our data across these partitions. And we have this partition key that we define for our transactional store. It defines how data is spread out across the different partitions within Cosmos DB transactional store. That partitioning strategy doesn't apply to our analytical store. The analytical store is written out in the chronological order in which the data comes in. So by default, we have a single set of partitions associated with a single transactional store all up. We've recently announced some functionality, and Rodrigo, maybe you want to talk to some of the new partitioning characteristics that we can enable through custom partitioning.
Exactly. So today, again, recap. Customers need to define a partition key for transactional store. They don't need to worry about analytical store. We do the partition for the customer. But for really big data volume scenarios, customers may need to define a custom partition. So we have this in preview. Customers can define another copy of analytical store with the partition key they want. That's a key functionality. It's in preview now.
Perfect. It's not covered in the learning part, but definitely go and look it up in the documentation as you work through this content on your own.
We have a very nice video about it in YouTube, Azure Cosmos DB live TV channel.
Absolutely. Go check out our YouTube channel as well. Good call out, Rodrigo. We touched on design scenarios. So I just want to close out that there are two things that we've spoken about that we haven't had a chance to drill into in today's session. The one is we focused on the SQL serverless characteristics that are available within Synapse. We also have that Spark engine, and that Spark engine is not something we had a chance to drill into. It provides similar functionality to what we've got in SQL. It just leverages the Spark engine. We provision it in a different way. It's a provision service that is done on a vCore level, whereas in the SQL serverless, it's a serverless function. So you pay for the actual query operations that you perform rather than the time that you have vCores running. So there's some differences from a provisioning perspective as well as the functionality. One of the things that Spark allows us to do is to write back. So you can write back the result set that you've created when using Spark to the transactional store. You'd never write directly to the analytical store. We always have that auto-sync process that writes the data to the analytical store for us. But you can write directly back to the transactional store using Spark. And it's that functionality that some of those other patterns that we spoke about earlier are leveraging in order for us to enable those end-to-end solution patterns for you.
And earlier today, I was answering customer questions. They were willing to do some analysis on top of analytical store using Synapse Link, and they want to store the results in SQL, Synapse SQL dedicated pool or SQL DB. Spark is a perfect tool to do it. So Spark allows customers to write this data not only back to transactional store, but to other transactional databases we have on Azure.
Perfect. Let's wrap up. We're almost at time now. I just want to quickly go through what we've learned today. So we said we were going to cover a lot, and we have covered a lot. We've spoken about the transactional and analytical processing patterns. We've kind of explored some of the workloads that we typically see customers have. But this applies to all industries. We chose a few to demonstrate, but this is not something that is constrained to a workload characteristic. It is something that is applicable to all workloads that have operational data running in Cosmos DB today. The HTAP scenarios in the context of the Synapse Link, what do you want to enable and what is needed to enable it with the Synapse technologies? We've spoken about that. We've gone into a lot of detail around the analytical store itself. specifically understanding what these well-defined schemas look like, some of those constraints that we have or rules that we have in terms of how we map from the NoSQL document data into a relational structure that we can query. And we've covered the different types of schema that you would need to create in order to enable your analytical processing. And we briefly touched on the functionality that's required in order for you to write back. We didn't get a chance to do a demo, but we did speak about that is enabled through the Spark capabilities within Synapse. And that's it for our today's session. Please go and explore the Learn module itself. It's linked in the slides here. It's linked from the session details as well. The design hybrid transactional analytical processing will talk you through all of these concepts again, provide you with examples similar to what you've got here. And then the other modules that follow on from there will go into much more detail around how to do some of these steps, both in SQL as well as in Spark, which again, we didn't get a lot of time to cover. And that's it for our session today. Thank you very much for joining us, and have a good build.
Yes, thank you so much.